Good morning everyone. Today we are going to see mechanics of material subject. In that unit 3 cylinders, principal stresses and strains. The first topic is thin cylinders. So here we going to follow one condition. When the thickness to the diameter of the cylinder is less than 1 by 20, we call it as it's a thin cylinder. So T is the wall thickness and D is the diameter of the arrangement. Here we are finding two kind of stresses. One is circumferential stresses, another one is longitudinal stresses. The formula for the circumferential is PD by 2T and for longitudinal is PD by 4T. And coming to the example problem, this is a sample problem for finding the hoop stresses and longitudinal stresses. A mild steel pipe of diameter 1.3 meter and thickness 12 mm is subjected to an internal fluid pressure of 1 Newton per millimeter squared. Calculate hoop stress and longitudinal stress. So they have given diameter of the pipe, thickness of the pipe and internal pressure. So we can use two kind of formula. One is PD by 2T, that is for hoop stress. Another one is PD by 4T, that is for longitudinal stress. Substitute the values and get the answer as 54.16 as hoop stress and 27.1 as a longitudinal stress. And for the second example, this is the hollow cylinder having a 750 mm diameter and 2.5 meter long, has a shell thickness of 10 mm. If the drum is subjected to an internal pressure of 2.6 Newton per millimeter square, determine change in dia, change in length, change in volume. So you do the conversion of given data, and we know the formula for change in dia is PD squared by 2T into 1 minus 1 by 2 into mu. So this is the formula for change in diameter. Substitute the answer and you get the answer as 0.296. And second one is we going to calculate change in length. So that is change in length is PDL by 2TE into half minus mu. Substitute the answer and get the answer as 0.232 mm. And the final one is change in volume. So we know the formula PdV divided by 2TE is 5 by 2 minus 2 mu. Substitute everything. Here you have to use one more formula, that is volume of the arrangement, that is area into length, pi by 4 d squared into L. So substitute that for finding the V value and you get the answer as 973,885.71 millimeter cube. And coming to the thickness, a thick cylinder, here the ratio for the arrangement is less than 20. That is D by T ratio is when it is less than 20 means it's going to be a thick cylinder. So here the hoop stress is not uniform. It is maximum at inner circumference and minimum at outer circumference. So these are all the formula we are going to use: radial pressure formula, circumferential or hoop stress formula, and circumferential strain formula, longitudinal stress formula, shear stress, volumetric strain, and strain formula for finding the stresses in the thick cylinder. So this is the example: a pipe of 600 mm internal diameter and 800 mm external diameter contains a fluid pressure of 8 Newton per millimeter squared. Find minimum and maximum hoop stress across the section. Also sketch the radial pressure distribution and hoop stress distribution across the section. So they have given D1, D2, so we can find R1, R2 from that. And pressure of the fluid is P1 as 8 Newton per millimeter squared. So they are asking the hoop stress sigma C, and they are asking to draw the arrangement, that is radial and hoop stress distribution. So we know the formula for radial stress and hoop stress. Substitute the value, that is B by R squared minus A. In that you substitute the value of R as R1 and another equation R as R2 in the second one. Here the P1 as 8 Newton per millimeter squared and P2 as taken as 0. So you are going to have two equations. Solve that. You are going to have A and B value as 10.3 and 1645715. Now coming to the substitution of AB value in the equation. So take the hoop stress formula, substitute the AB form answers. You are going to have, get the stresses like 28.58 Newton per millimeter square, that is hoop stress maximum. Another one is when you substitute the R2 value as 400, going to be minimum hoop stress, that going to be 20.58. So for this value, you draw the distribution diagram. You keep the radius in the x-axis and stress in the y-axis. So that's all. And coming to the next topic, principal plane and Morse circle. So principal stresses are the normal stresses acting on a principal plane. There are two principal stresses which are acting mutually perpendicular to each other. The greatest value of the principal stress is called major principal stress, and least value is called as minimum principal, that is minor principal stress. And the methods for determining stresses are analytical method and graphical method. The graphical method also called as a Morse circle method. And these are all the cases we are going to solve. Case 1 is a body subjected to direct stress in one plane, and case 2, body subjected to direct stress in mutually perpendicular directions. Case 3, body subjected to simple shear stress only. Case 4, body subjected to unequal and unlike direct stresses in two mutually perpendicular directions. And case 5, a body subjected to direct stresses in two mutually perpendicular directions accompanied with the simple shear stress. Now we are going to see one example for this cases. Here they have given principal stresses at a point in the section of a heat exchanger shell. That is 18 megapascal tensile, that is sigma 1, and 10 megapascal compressive, that is sigma 2, that acts in the opposite direction. So minus value is taken for compressive. So minus 10 megapascal, that is minus 10 Newton per millimeter squared. And they have given the angle, that is 60 degree. So they are asking the normal stress, shear stress, resultant stress, maximum shear stress. And for analytical solution for this case is, we are going to use the normal stress formula, sigma 1 plus sigma 2 by 2 plus sigma 1 minus sigma 2 by 2 into cos 2 theta. Substitute all the value, you are going to have minus 3 Newton per millimeter squared. Same thing, tangential stress, sigma 1 minus sigma 2 divided by sigma 2 divided by 2 into sin 2 theta. Substitute all the value, you are going to have 12.12 Newton per millimeter squared. Coming to the resultant stress, sigma n squared, that is normal stress squared plus tangential stress squared in the square root, we are going to get 12.485 Newton per millimeter squared. And the final calculation is maximum shear stress, sigma 1 minus sigma 2 by 2. So that going to be 14 Newton per millimeter squared. So this same solution is solved by graphical method also, that is Morse circle method. Here we are going to use compass. First you draw a horizontal line and you mark the distance of OA for a particular scale of 18 Newton per millimeter squared, and the second stress is compressive, that is minus value. So you draw the value of 10 Newton per millimeter squared in opposite direction, that is OB, in opposite direction. So OA is on positive direction, OB is in opposite negative direction. Now bisect these two, that is the total length AB is bisect at a distance C. So C is the center and AC or BC are the radius. You draw a circle, that is called Morse circle, and OA, with respect to OA from the C you draw a line, that is 120 degree. That line intersect the Morse circle. That point is named as D. From D draw a perpendicular line, and that is intersect the line OB and name it as E. Then connect D with O. Now we are going to measure the distance. So the measurement of OE is known as normal stress. So that when you use the scale means you can do the scale reverse calculation and you are going to have minus 3 Newton per millimeter squared. And tangential stress is DE, that is perpendicular line. So you measure the distance in your scale and do the reverse calculation, scale conversion, you are going to have 12 Newton per millimeter squared. And resultant stress OD is same thing, you measure and do the reverse calculation for finding the exact value. that is 12.4 Newton per millimeter square. And the last one is maximum shear stress, that is radius of the Mohs circle. It may be BC or a AC. You measure the distance, that going to be, you are going to have 14 Newton per millimeter square. So that's all. Now you can see the analytical and graphical method both are having same answers. Thank you.